Hello students, in this video we are going to discuss one problem comes under quantifiers. Using the quantifier rules, rule EG, rule UG, rule US, rule ES. Okay, so using these rules, let us prove this problem. Taken 18 to 1, using the indirect method of proof to prove that for all x, p of x or q of x imply for all x, p of x or there exists x, q of x. To prove for all x, p of x or there exists x, q of x from the premise for all x, p of x or q of x. In this problem, we can use indirect method. Uh, in this problem, particularly use the contrapositive method, comes under indirect method. What is the contrapositive rule? P imply Q is equivalent to negation Q imply negation P. So using the contrapositive method, let us prove negation of for all x, P of x or there exists x, Q of x implies negation of for all x, P of x or Q of x. Now introduce the premise rule using rule P in the first step. Negation of for all x, P of x or there exists x, Q of x. Now negation move to inside using the De Morgan's rule in the first step. Using rule T, we get there exists x for all x converting into there exists x negation form. P of x converting into negation of P of x or converting into and there exists x converting into for all x Q of x converting into negation Q of x. So using the rule De Morgan's law in the second step. Now using the simplification rule in the second step, it can be split into two terms. There exists x negation P of x and also there is for all x negation Q of x. In the third step and fifth step. In the third step and fifth step. Now from the third step using the rule extensional specification, because in the third step contains a quantifier, extensional quantifier. So remove this quantifier using the rule extensional specification. So we get negation P of A in the fourth step. So in a similar manner, in the fifth step using the rule US, that is universal specification. So remove the universal specification quantifier, we get negation Q of A in the sixth step. Now comparing fourth step and sixth step, we get negation P of A and negation Q of A using the rule P comma Q imply P and Q. Now using De Morgan's rule, it can be converted into negation of P of A or Q of A in the eighth step. Now introduce extensional generalization, because the final result contains a quantifier inside the brackets contains the quantifier for all x after using the De Morgan's law. So now introduce extensional generalization in the eighth step. So there exists x of negation P of x or Q of x. Now using the rule De Morgan's law, the negation comes into outside. Negation of for all x, that is there exists x converting into for all x inside P of x or Q of x. So it is the conclusion. So finally this conclusion comes from the premise negation for all x, P of x or there exists x, Q of x. So it is the final conclusion. Thank you.